Hello everyone. Welcome to the solution of LeetCode problem 1306 named Jump Game 3. In this problem, we are given an array of non-negative integers and you are initially positioned at the start index. Now, when you are at index I, you can jump to either I plus array of I or I minus array of I. Now you have to check whether you can reach any index which has the value 0 or not. Notice that you cannot jump outside the array at any of the time. Now let's consider this first example. Here, the array contains 7 elements, which is 4, 2, 3, 0, 3, 1, and 2. Now our starting index is 5. That means we will start at the element 1. So from 1, we can go either 3 or 2. That means we can jump 1 unit in the right side or left side. Suppose we are at this element 3. From 3, we can go this 2 or become out of bound if we jump into the right side. So from this 3, we will get into this 2. Now from this 2, if we jump 2 unit in the right side, we will reach this point where the value is 0. So in this case, it is possible to reach any of the index with the value 0. So we have to return true. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken the same example. Now, as we will solve this problem by using the BFS. Here, why we will apply the graph traversal algorithm BFS to solve this problem? Basically, for each of the position, we have two decisions. Suppose this is the position I, so either I can go I plus A of I, or I can go I minus A of I. So here, for each of the I or for each of the point, we can go into two direction. Now for this point also, we can also go in the two direction. For this point, we can go also in the two direction, and we will keep expanding the graph, and we will check whether any of the value is equal to 0 or not. If any of the value is equal to 0, we have to return true. Otherwise, we have to return false. Now, let's understand how basically the BFS or level order search work in these scenarios. Now here, our graph contains 7 elements and currently our start element is 1. Now we are at this element 1, which has the index number of 5. Now from this 1, I can go 1 unit right or 1 unit left. So here I can go 3 or I can go the value of 2. This 3 has the index number of 4 and this 2 has the index number of 6. Now we have visited the first level, which is 1. Now we will cover the second level. The first node of the second level is 3. So from this 3, we can go this node 2 and we can jump 3 unit in the right side, but we will go out of bound. So we cannot do it. So we can move to the element or the node value 2, which has the index number of 1. Now we have processed the node 3. From node 2, we can go 2 unit in the right side or 2 unit into the left side. So from 2, we will go to the node 0, which has the index number of 3. So we have processed this second level. Now wait. While processing this node 2, we have found that we can go to the node which has the value 0 at any of the point. So here, in this case, we have to return true. So what is the criteria? At first, we will go to the top node, which is 1 at the starting point. From 1, we will get back to the 2, which is this. From 2, we will get back to the 0. So from 2, we will get back to this node 0. Now, basically, this is how the BFS algorithm will work. And the overall time complexity of this algorithm is big O of n, which is the linear time complexity. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named canReach, which is an integer of vector A and a starting point. Now we are taking a queue and inserting the starting point into the queue. Now we are continuing this loop while queue is not empty, and we are storing the front element of the queue. And if the front element is 0, that means we have reached the destination, we have to return true. Otherwise, if the front element is less than 0, we have to continue. That means this node already been visited. Otherwise, if the front element plus a of front, that means if it is possible that we can jump into the right side, which is less than a of size, that means we have to push the front plus a of front into the queue. After that, if it is possible to jump into the left side, that means front minus a of front greater than or equal to 0. In this case, we have to insert front minus a of front into the queue. After that, we have to assign a of front equal to minus a of front. This negative value indicates that this node front is being visited. Now, while completing this loop, if any of the position it did not return true, we have to simply return false. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.